Hey, this is Passy from Passy's World of ICT, and if you want to find me on YouTube, I'm the guy with the white hat. Yeah, a little bit of a backstory on the white hat and what we're doing today with functions. I got this white hat in Buenos Aires in Argentina in South America, and it was kind of near the end of this trip I did to South America. And yeah, it was a really hot day and I'd gone down to this market and I thought, oh man, I need a hat. And so yeah, I bought this hat, but later on, like the tour guide told me, you know, that hat's made out of paper. Don't ever wear it out in the rain. Yeah, we got some photos here. So this was like South America. Wow, you know, like functions. The function of this holiday was to have an epic time and get to Machu Picchu, because that had always been my goal, and walk the Inca Trail. Now the inputs to the function, what it required money, because it was expensive to travel around South America, especially since you need guides and that. So money was a big input, and I worked really hard for 3 years, like doing a day job, doing some programming, taking photos as well to get some cash to get enough money to go, because I really wanted to go around like Chile, Argentina, Peru, and Bolivia. Didn't get to any of the other countries, but we'll have to go back there some other time and do it. And yeah, so the other input was time, like you needed time off work to go there. And a third input to this function of the holiday was that you really need to learn some Spanish. You'll have a much better time if you know some Spanish, because people over there, everyone speaks Spanish and hardly anyone knows English really well at all. But yeah, look, just to show you around, the pictures, the mountains are brilliant. People are really friendly. You know, like this guy sort of taught me how to play a bit of a wood flute here, and we had a jam together. That was fantastic. Hung out with some racehorses down in, where was that? That was down in Chile. Of course, walked the Inca Trail and got to see the magic Machu Picchu. Another thing that you don't think about is the weather there, and it can close out really quickly. Like this big mountain behind there is called Huayna Picchu, and you can do this kind of like all-day walk up and down that. But the trouble was, the next day when we were scheduled to do that, there was just this tropical rain that just kept going for like about 4 hours, and they said, no, it's too dangerous, we can't even get to the mountain and go there. And this last picture in the corner, this was a guy, like, you know, the big guys will wear a fancy suit, drive a Ferrari, and have a big watch in the Western countries. This was the big guy in charge of the village, and he had like the big hydrangeas hat of flowers and stuff, and he was the boss man of the village. And there was some big function on when we went there, in a market and stuff. But his son, you know, the son had to wear the hat as well, because he's the boss's son. But you could see he was really sucking it up and hating it, like, you know, I just want to be off with my friends playing soccer, Dad. Come on. Anyway, let's get back to the lesson. We could talk and talk and talk about travel, but look, it's a great thing, and we recommend everyone does some travel. So we've already looked at some functions in Visual Basic. Okay, so there's built-in functions in most programming languages, and they really help you out with things you need to do. So we've already looked at the VAL function in a previous lesson, and that was when you had something coming in off your form that's text, and you need to change it into a number to do some mathematics on it. And its kind of friend there is the casting function, so we could cast something as a double. That's another way of converting text off your form into numeric sort of variables which you can then use in your program. So you'll notice with these functions, at first it has the name of the function, VAL or CDBL, and inside some brackets it has what you're getting a hold of to put into that function. So we wanted to get the first number text off the screen there and put that into this value function to get it converted to a number. So you have the name of the function and then what's going into it in brackets. So that's something I've already seen and used. So the format is that you have function name, then you have brackets, and that's the input value that you want to process using that function. So functions work out the value for us, just like hard coding something like 2*3 in Visual Basic will work out some maths answers for you. You can also do answers within functions rather than doing hard coding. So sometimes you pass more than one parameter into a function. So here when we were doing the rounding off lesson, you can see here that we've got this val function that's converting it into a number, and that's nested. It's kind of put inside this bigger function. So we've got like a function here inside another one, and this is the math rounding off function. And on that, we were putting comma 2 because we wanted to round off to 2 decimal places. So into that built-in math rounding off function, we're actually kind of working out the number value and passing that into the function, as well as the number 2, which was saying to the function, hey, we want to round this off to 2 decimal places. And in this other example here, we've actually got 3 things going into the function. So again, we're using the math rounding off function. We're putting in the number we want to round off. We want 2 decimal places, but the technique we wanted to use for the rounding was the midpoint rounding away from 0, because we found that gives the best answer. So this function actually had 3 things going into it, and what would come out of the function, just like those great experiences came out of our holiday after we put in the money and time and learning Spanish, is that we'd get a rounded off number here, which we could put into a program variable in our program. So how functions work, you need to think about it like a vending machine. This is a really good kind of analogy or a way of thinking about functions for if you get lost with everything. So we've kind of got the external subroutine, and then we've got the actual function that processes the inputs which you've sent into it. So here we've got the external person here. She's going to put money into the machine. That's one of the inputs, or a credit card. And then she's going to pick a number on the keypad, and that's like the second input. So these inputs go into the machine, and in the machine we've got all the candy bars there. So she's done payment and selected number 53 here was her numeric selection. So that's kind of the inputs going in, and passing different values, like if she'd passed in a 56, she would have got some M&Ms, but I think the 53, the Kit Kat rocks. That's a much better choice. Or if you're American, you can get some Oreo cookies there if you pick whatever number that is. I think that was something in the 40s. But anyway, after you've picked your number, depending on what number you pick, what you've put into there, the Kit Kat or different things will come out. And it's the same when we're writing our own functions for inside programs. Depending on what you put into that function, you'll kind of get a different output coming out of the function back to you. So you're kind of like the subroutine. That's where we put some code in there to set up the function, what we're putting into the function, what we're hoping to get out of it. And then we have some more program code that's separate, that's like the vending machine that actually does the function. And we have this result passed back or returned by this function machine, all right? So if you get lost during this presentation, just try and think back to the vending machine where you're the person, you're the subroutine that wants to do something. The vending machine's going to perform the function for you. It needs some inputs and it's going to give you some outputs. So that's kind of the idea of functions. All right, let's look at user-defined functions. So there are those ones that are built into Visual Basic for doing your rounding off, but we're going to write some customized special functions of our own to do numbers, money, and dates. So the 3 different examples we're going to look at. So what we've done with this was, rather than have things input on the screen and have to do validation and conversions and all these things, we just kind of had this blank screen really, and the only important thing in it is this button, Functionate Now, the Functionator. So what will happen is when you press Functionate Now, it's going to do some hard coding. So we had hard coding here. This is GST, like a tax, like VAT tax or sales tax that they've got here in Australia. So if something costs $25, right, if that was the wholesale price, before they can sell it to you and you buy it, they've got to add on 10% GST. And so this function works it out and works out, okay, 10%, 1/10 of 25 is $2.50. And we just get the output put in a message box. So it's a lot easier to just do hard coding behind the form here, hidden out of sight, and then just have it tell us what went in and what came out of the function just via a message box, okay? So this is kind of fast-tracked. And how that works inside the program is, we'll show you this GST one now. We're not expecting you to understand this straight away, right? We're going to have more presentation here where we break it down into steps, and plus we're going to give you 3 different example functions. So look, by the end of the video, you're probably understanding it. Now, functions we've found with our students is something that people either get straight away, like some people just understand functions and go, oh yeah, okay, yeah, just got to set something up, put it in the function, have some code written for the function, and yeah, we get an answer. That's really cool. And they can do it pretty quickly. Other students, it's sort of, there's a lot of special ways or just things you need to be careful about when you set it up. And some students find it overwhelming, really confusing. And so For them, it's best to watch all of this video, but for other people, just download the resources that are with this video and have a quick read through them, get the code, copy and paste some code in, do the challenge task we're going to have at the end. And they can get up to functions much quicker. So if you're a teacher watching this video, there's a number of different ways your students need to do this learning. Some can just be given the download materials that you've got for them and they'll be away straight away and understand functions. Other people, it's going to take a little while longer. So look, this looks super complicated right now, but just to give you a high level view of what we're doing, we're putting in a wholesale price value of 25 for our $25. And we want to calculate the GST. So we've got this variable DBL GST to store that answer in the tax. And we just call this function, which is called calculate GST. And in that, when we call that in brackets, we're just going to pass in the wholesale price. So it's not that different to doing val or CDBL or the math.round. You've just got the name of the function here and you've got what's going into it here. So from this subroutine, this is all code in a subroutine, we're just going to call the function. When we get the answer back, we're just going to format it into dollar and cents format here and put it out in that message box, as you can see over here. This is the actual function we had to build. So we had to create our own custom coded function, which takes in that pass parameter of the input price and sort of works out the GST and returns it back up here so we can get the answer, all right? So you kind of have some subroutine code that you set up, you call the function. If it was a built-in function, Visual Basic would just do all the magic behind the scenes and we don't even see it. If it's one you're writing yourself, like a custom one here in Australia to do sales tax, you have to write the function code yourself. Now notice that here it was called wholesale price. Coming into the function, it's called DBL input price. So these guys aren't usually the same name, all right? So don't get concerned that, hey, where's the wholesale price? Where did it go? These guys are the same thing, but they're just called different names, and that's something else you need to learn about functions. So let's have a look at this in a bit more detail. So we have the code first in our subroutine, just like we would with a built-in function. So we're setting the GST price at $25. We're making a variable here where we're going to store the returned value after the function's done its stuff. And then we've got this code here, which is to call the function. Now, the important parts of that code, let's have a look at them. The first thing is the name. Calculate GST is just a name we made up for the function. So this is our own user-defined or program-defined function. So we're making up our own name for it. So the name we chose was just calculate GST. Now you could have called it, if you wanted to, get GST or apply GST or create GST, whatever name you want to do, that's the name of it. In the brackets here, we put what is the program variable that we've already got in our program that we want to pass into that function as input. So the wholesale price is what we're putting in. You can also, as well as a variable name here, you could hard code a literal number like $14.99, 14.99, and just put that in the brackets. It doesn't have to be a program variable name. And when the function's finished, what it'll do is it'll return back up here. It's done all the calculation and we've just set it up so the answer from all of that will go into DBL GST. All right, so they're the kind of three main things you set up in the subroutine for calling that function and getting it to do the work and getting the value back in up at your subroutine here. Now let's look at how you write your customized function. So unlike the built-in functions, we've actually got to write the code for our own custom ones, our programmer-defined or user-defined functions. So we're kind of like building our own little vending machine here to do the processing. So we've got the name of the function here, some processing, and then we have an end function. So you'll notice it kind of looks a bit like a subroutine where you have public sub, name of the sub, and then end sub, except these are called public function when we write them, okay? So they're called from up in the subroutine. So remember, think of this person out here saying what they want to do as their inputs. That's all getting set up here. And then we're going to go down inside the vending machine and actually get some result for them based on what they asked for. So the function names need to be identical. So this is very important. We decided to call it calculate GST. So this part here, this separate self-contained module or function. This goes right down the bottom of your program, so it's not inside the subroutine. We usually put the functions right down the very bottom of our code so that we can just go down there if we need to see what the functions were doing, but we don't put them close to the subroutines or in the subroutines. They just go right down the bottom of the program near the end class. So anyway, those names have to be the same: calculate GST, calculate GST. Now, for dimensioning what GST is going to be, the answer, that goes right up the end here. So right up the end, see how we've got this as double? That's actually setting up that calculate GST in memory is going to be processed as a double, meaning we can have decimals in it because we want to have both dollars and cents. So we've got double in there. All right. So that's important. Down here, when we have the calculate GST and populate it, we need to make sure we've used the same name as the function. Okay, that's very important. And then we return that value. So we set it up to go back up into the subroutine where we called this from. And so that has to be the same name, and you need to have an end function on the end. So this is very important. Calculate GST. If that was the name we chose, we've got to name our function as that, or Visual Basic won't be able to find the function. And inside there, we need to also use the exact same spelling and name. So that's very important. Now, the passed in value here is this DBL wholesale price, but notice in the function we've defined it as a value that's coming in, and it's set up to be a double. Okay, so it's expecting numbers or numbers and decimals to come into this function. So these guys aren't the same name. This one was called wholesale price. That's what we were dealing with up in the subroutine, but this is just a generic one which we use inside the function. Okay, so those names usually do not match, like they do not match, and that is not a problem. That's actually the way it's supposed to be. Now, the function will do all its work, and with this return calculate GST, that's actually going to put that back up here as the answer, and because we've got this set equal to, that'll end up going into DBL GST, all right? So this is going to go off, calculate the GST, work out the 10%, and then put it back in here. All right, so when we're working out the 10%, whoops, we've just dimensioned a result here, worked out 0.1, 10% of times that input price they've passed in, and just put that into your calculate GST and return that back up the top. Now, you don't actually need this return. We found you could code this up without this in here and it still worked okay, but it's proper programming practice to have the return down the bottom of the function there. So this, as we said, goes right down the very bottom of the program code. It's not there next to your subroutine. It's not inside your subroutine. It's a whole separate thing which you can just put right down the bottom of the code. All right, so doing a function versus doing hard coding. Why would we do a function, right? If a process is only going to be done once, there's no point in doing a function. So we have shown in the code that we've given you in the downloads, if we want to triple a whole number by multiplying it by 3, we just hard coded here that the number originally was 1. We're just going to do 3 times that number, 3 times 1, and put out the answer. So this is all done by the program. We get a message box, the hard-coded value of 1. If we triple that, multiply it by 3, the answer is 3, and that's the answer. Now, you can write a function to do it as well, okay? So here we've just written a function to do the same thing. So we're going to set the value as 1. We're going to have this function called triple the integer, all right? And triple the integer, we're going to have to put some function code down the bottom of our program. It's just going to take in a integer whole number, multiply it by 3, and return that back up here and give you the what it is times 3, and you can put that into here and then display it out in the message box. So you kind of get the same answer. It just says, oh, this is the one where we did the function, the passed value of 1. If you triple that passed in value, you get the answer of 3. Hopefully you can see that it's a little bit small on the slide. Now, there's no way you would do all this work to have input values, return values, actually write a whole little function to do it for something like this, okay? We're only doing the tripling once. It's not like tripling is something like GST. So if we had all these different wholesale prices going on in our program, and each time for each of them we need to go off and get the GST, the 10%, well then it makes sense to have this function where you can just put your whatever value you've got at the moment in there, bang, down it goes to function, back up comes 10%, the GST. Or if we were reading in an input file, it had all these wholesale prices on products, and for each product, we wanted to work out our 10% GST. It makes great sense to have a separate function to do that. So functions are for kind of repeated tasks that we need to do a lot of times for a lot of different input sources. But for something like this, it's ridiculous. It's just silly to write a function. It's so much extra work, as you can see on the bottom half of this slide. You would just hard code it right into the program. That's a much simpler way of doing it. All right, now function versus a subroutine. What's the difference between these two guys? Because we kind of saw that they're similar, that you have these separate things written, and they're kind of down the bottom part of your program, and another subroutine calls them and tells them to go do them as a separate sub-process. So what is the difference between the function and the subroutine? Well, this tripling the number, we could write a subroutine to do this. So up the top of our program, we've just put some variables here so that they'll be accessible all over the program of what the original value is coming in and what the 3 times or tripled value answer is going to be. So we set that up at the top of the program, and then when they click that button to do functionating, it's going to take that value that we've defined and set it to 1 for the input. It'll just set the output now to 0 because it hasn't done anything. And we're just going to go to a subroutine called triple the value, and it's going to do the actual multiplying by 3. So a subroutine really is kind of a lot like a function. It's just that you don't have anything in the brackets. So there's no values passed to the subroutine. The values are sitting in these memory variables, which we've defined as global up the top of our program. So any part of the program, including this triple the value subroutine, is going to be able to get access to them and change them and see them. So we just write this tiny little subroutine here, public sub triple the value brackets, and it just multiplies our number by 3 and gets the answer for us. Now, we're doing it with 1 line of code here. So again, it's ridiculous to go to all this effort. What we should be doing is just hard coding it in, as we showed you previously. So look, subroutines are used when you've got something involved to do. So you don't use them for a 1-liner of code. That is just ridiculous, as in this example. Subroutines are used for modularizing much more complicated sub-processes. So like if we had a input form, and like in that password entry program where they've got to put in a password that's got to have, you know, letters in it and numbers, and it's also got to be at least 8 characters long. It makes sense to have a subroutine to go through all that complicated string processing and checking and do that, and not have it kind of up in the main part of the program. So that makes sense when you've got quite a few things to do and you just want to break it off to keep it as its own little module and not have one giant super complicated slab of code for people to go through. That's when you use a subroutine. You don't use it for 1-liners like tripling a number, obviously. Okay, now our final version, and you might want to take a break here and pause the video because we've been through a bit of information. So if you want to take a breather, we're just going to grab some water here. We're so lucky in Australia we've got fresh water. You know, when you travel overseas, you've got to buy bottled water all the time because you can't drink their local water, which was really heavy to carry. Like when you're walking that Inca Trail, you've got to carry litres of water with you, and each litre weighs a kilo, and that's another kilo in your day pack. And yes, water's important, and so's functions, and let's get back to them. This is our last example. This is the days different function. So we're going to work out how many days there are in between 2 dates. So like if it's the 10th of April, how many days will it be until it's like the 18th of April? Well, 10 to 18, 18 minus 10, that's 8 days, right? So that's a fairly simple one. Or if it's the 10th now and we want to know, and we've sort of got something due to be done by the 12th, how many days do we have to work on it? Well, 12 minus 10, we've only got 2 days to work on it. All right, so it's just going to calculate days difference. Now, this is really useful for job tracking systems. A lot of apps are written to track work and things like that. And so we could compare a job's completion date with today's date. And if it was completed in the past and someone should have already paid for it, we could work out, okay, that job was finished 7 days ago, the person still hasn't paid us, they're kind of 7 days overdue with the money. Let's get in touch with them and follow that money and payment up. Okay, we could work out that a job was supposed to be finished in the past, but we're now past that finish date. So how many days past it are we? How overdue is that job from being completed? That's another thing we could do of a job tracking system. We could report all the jobs which are running more than 7 days late at the moment. So there's 7 days passed over the expected completion date. So that would use days difference. We could be reading in our file of all the jobs our business has at the moment, or maybe it's a database table that we're reading in as input, and looking at that job tracking data and working out jobs which should have been completed already and how many days overdue each job is, and putting that out on a report. And another great use, which we're going to use in a later lesson, is you can actually work out someone's age using the days difference function, because how old they are is basically the date they were born all the way up until today's date. How many days is that? And then just take that number of days from this days difference function and divide it by 365 and do some maths rounding off to get it into a sort of whole number of years. Like they might be, 18 years and 6 months old, but that's just 18, okay? So we sort of do this rounding off and stuff as well. So we're going to do a whole full separate lesson all about dates because they're really important in processing. But today in this functions lesson, we just want to show you this days difference function, because this is going to be a very useful function which we will be using again and again later on in different parts of our course. So there's two input parameters, the first date and the second date. So here we've just set them up and we've hard coded them in, that we've got the 20th of the 3rd and the 28th of the 3rd. And we're going to have this function called days difference. We're putting in date 1 and date 2, passing two things into the function. So we've just, rather than have text boxes on the form and have to do validation or read in from a file or anything, we're just hard coding them straight here into the file, and we're hard coding them as dates, okay? And this code's going to set up our call to the function. So the function's called days difference. So we need to write a whole kind of slab of code down the bottom of our program that starts with public function and finishes with end function, and have the correct name here, days difference, and right up the end, remember to dimension it to what kind of variable type you want it. So we want this days difference just to be a whole number, so it needs to be dimensioned as integer. So yeah, this is a bit tricky too, that the actual, usually you'd have, like dim days difference as integer. When you're doing functions, the kind of as integer ends up right up the end here over the right hand side, which can be confusing as well. Because in the middle there in between, you need to have the inputs that are coming into the function. In this case, it's a start date and an end date. And notice the names of these are not the same as the names back here in the subroutine where we're calling it. And that's very, very typical. That happens all the time, okay? And that's not a problem. You've called days difference. It's just actually got the numbers and the dates here and just puts them into these variables, which it's going to work on down inside this function. Now, this function is then going to pass back, once it's worked out the answer, the integer number of days, so how many days it was in between those two dates, so the 20th and the 28th for the 3rd. So it's going to work that out and put it back up here where it's going to tell you the number of days, and you'll be able to access that in your program. Now, the interesting thing is we've kind of got something really involved here. I think I got this off Stack Overflow, the best place to look at code. Now, there's a lot of different ways of doing days difference and things, but this seemed to be the best one that I found, and I've tested it and it works really well. That we just have our end date, which came in to the function here, and we've got the start date, which came into the function up here. And we're just doing the subtract function. So this is a built-in function in Visual Basic where you can actually subtract two dates to find out by how much they differ. And we want the answer not to be in months or years. We want it to be in the total number of days. So we put dot total days. So we didn't kind of have to really write our own function. We use some internal Visual Basic date function here to actually do it for us. We just had to pull it all together and use math.floor, which is a way of rounding off, which works similar to truncating. If you've watched our lesson on rounding off and truncating, we didn't actually mention math.floor, but math.floor is another way of just chopping off the decimal value, not worrying about what it is and getting rid of it, disposing of it, so we've just got a whole number. So notice we call the function days difference, so days difference has to be the thing that gets returned back up to here. When it is returned back up to the subroutine, it'll go into int number of days. And on our screen, for our program, because remember we're just doing this with message boxes and hard coding inside the program like this, this is what it did. It just popped up a message box, told us the first date was the 20th of the 3rd, second one was 28th of the 3rd, and the days difference, as we'd expect, is 8 days between those two dates. Okay, so that's the days difference function, a function which takes in 2 dates, and inside it we were just kind of cheating a bit, I suppose. We were just using functions that were already available within Visual Basic, so we kind of got functions inside other functions here to do all of the work. And this generic function of days difference is going to be used many times in quite a few projects we're doing and ones that you're going to do. So it's a really useful one to have. So get the downloads for this lesson so you've got a copy of the code for doing days difference. Now, we haven't done validation. We were trying to do hard coding in our program just to keep it simpler, but we should really mention our good old friend validation, which we've done quite a few lessons on, and our students really love validation. But it's, look, it can be tricky, and it's, you know, you have to do a lot of testing for it, and so students don't like doing it, but it's essential. You know, a good app is going to run, put up with silly input from users without crashing the program. So you've got to have this in here. So if you let a bad date come in, for example, that will crash the program. So we've got to have some validation. So we'll just show you how to do validation. So this was the code, same code as we had before. And we've just added in here some code to do some validation. And if it doesn't come up any good, give them a message and exit out of the sub so that the bad data can't go any further and it cannot create a program crash. So we've just used the built-in function. So Visual Basic has this great function called isDate. So your string value here, so to mention these as strings, so they're just in quotes, the string value there, and that could be something coming off a form or coming out of an input file into your program, that just has an isDate function check done on it. And for both of them, and if both of them are isDate, right, they're both good, that's going to be okay, and we don't actually have to put any coding in here. But else, if one of these doesn't pass the check, so it's not and both of them's correct, one of them or both of them's wrong, it'll drop down to here. What it's going to do is put out a message box, tell them they've got a problem with their dates, tell them what those values were, tell them it's a date error, and exit from the subroutine. So we can't go any further, because if we do go further, our program will crash if it has a bad date coming into it. You know, a date like kind of the 34th of the 14th, 2020 or something. You know, there is no 34th day in the month and there's no 14th month in the year. Okay, so you need that. If the dates are both valid, well then underneath that code we just looked at, the next thing we need to do is some casting, because these dates were string, like if they're coming out of a text box in a form or from an input file, they might be strings. So we're just using cdate, convert them to date or cast them into date variables, and then we can have them as dt date1. Because that function we're going to call days difference, it relies on having two values come into it which are both in date format, not in string format or number format. Those two variables coming in need to be in date format, okay? So we just set this up to use our casting or our conversioning here that's built into Visual Basic, another built-in function, so many functions in this lesson, and get them into date format before we put them into the call to the function. But look, it turns out you don't need this, because Visual Basic behind the scenes, without even using a function or telling us, if you've got something that's a string and you put it straight into a date field, it'll actually do all the casting for you behind the scenes. So Visual Basic kind of, notice how it's put these in light blue, the C dates are in light blue, and in the actual program, if you mouse over them, it gives you this little pop-up message that tells you, hey, you don't really actually need to cast these. But anyway, it doesn't hurt to put it in, and that's good programming language, programming kind of processing or habits for any language. So if you're using another language, where your input data had come in as string, you would need to kind of convert it into the date format for that language. So that's that. And then we call our days difference function, and let's go have a look at that. And just to be doubly sure, to protect against any bad data crashing out in this function, down in the function, we've also added validation, the same sort of validation here to check, is that date that's coming in a date, are both of those dates, okay? Now, it turns out that we don't really need that, but we'll explain that in a minute. But the thing we wanted to show you was that before we go down into the function to do processing, we can have this stuff and we can do a return. So we can use a return before the end of the function, just like we use an exit sub in a subroutine. So remember when we were doing that validation in the subroutine, if it was no good, you just do an exit sub and you get out of there so that it can't go any further and cause crashing and problems. You're the bouncer. You know, that person there at the door that wants to come in looks drunk and like they're going to start a fight or something. So you just don't let them in. You exit them out away from the club and they're not coming in. And that's what you're doing here. But we do it with return. So we're just saying, don't wait till the end of this. Let's get out now. Just return the day's difference and send them a -1, kind of stamping it that, hey, this is bad data because it's turned out to be -1, all right? So that might be something you have to put in a function. You might have to have some validation and do a premature return before the end of the function and pass it like some value like -1 to indicate that there's an error condition. So we don't actually need this. This code will never get done because, look, these things had to be passed in as dates anyway, the way we've set up our function. So what would happen was that upstream, if you tried to put something here to call a function, it would crash out at that stage, okay? So the upstream calling code, if that tried to put, you know, 34 for the 14th, 2020 in here, it would crash out before it even got down to the function here, all right? So that code's not actually needed, but we thought we'd show you that because you might need it in other situations to validate something coming in. If those dates were coming in as strings maybe, and you're thinking the function's going to do everything, it'll convert the string, it'll do the validation, and then it's going to find the day's difference. Well, yeah, then you would need this validation there to stop it crashing out inside the function. Okay, so that's it. There are examples of functions, and to make sure you understand them, we've got a challenge task for you. Now, we know you're busy and you may not have time, but look, it's best to just get our downloads for this lesson, and we've even got a little starter bit of code in there to help you out, but you'll have to make the form. So it's got a form here where you can put in a number, you click generate, it's going to double the number, halve the number, work out the number times itself to get the square, and do the number times itself 3 times to get a thing called the cube of the number. So we haven't done powers, I don't think, raising things to exponents and indexes and things like that, but you just use the hat symbol, which is kind of shift and 6 on your keyboard, and 2 if you want to square it, and a 3 if you want to cube it. So look, this would be the function actually that you'd use to cube a number. You just put the input integers coming in this function, just little hat, shift 6, 3. That'll multiply this number times itself again, so that altogether it's multiplied by 3 times. So when we put a 3 in over here, if you do 3 times 3 times 3, then you've multiplied it together 3 times and cubed it, and the answer will be 27, okay? So that's how cubing works. Hopefully you can remember enough of your mathematics for this to make sense. But look, if you do this little challenge task, that'll get you up to speed, coding your own functions, and getting everything working properly with the name, the things that you're passing in, and all of that. Now, further reading, if you're doing software development, VCE here in Melbourne, Australia, the book, the textbook, you've got the Jansen book. Subroutines and functions are just mentioned on page 71 in chapter 6 of that book, so you can have a look at that. And further reading also is the great Mark Kelly, a fantastic software development teacher from Melbourne that's now retired, unfortunately, but he has made, well, I mean, it's great for him because he's retired, but it's not so good for the rest of us because he used to make these great PowerPoints and share information that the rest of us could use of our classes and things. But if you go down to this section, the SD, Software Development Unit 3, Outcome 1, KK, Key Knowledge 06, there's a PowerPoint icon and you can get this presentation. And this is a really good one because it shows a fairly complicated function here that's going to be searching a string to find out if there is a number value contained within that string. So this is kind of, yeah, a really cool kind of example of using functions. And it also shows you, like we did, the difference between, I think, subroutines and functions and a couple other things. So yeah, go through that PowerPoint. That's got some really good material in it to further reinforce your knowledge of functions. And then to further reinforce your knowledge of Visual Basic in its entirety, go to our programming course. The YouTube is just where we store the videos, which are free, and you can watch them as many times as you like. Our actual full course is on the PasseyWorldOfICT.com website, okay? And if you click the programming button, you'll get into the programming course. Let's just find it and jump across there and have a look. No, that's not it. Oops, oops, oops. Where are we? Okay, Internet Explorer, here we go. Right, so we've got programming here, our programming course. So if you look at that, there's lots and lots of lessons. Now, a lot of them have free resources too, okay? So this one here that was all about pseudocode back at the start of the course, there's a little bit of an overview of what we covered in it. There are all the different things which are contained within the lesson. There's the free video you can watch all about how to do algorithms and pseudocode. And you can click here to download that presentation for free, and you just click that and that will come straight in there, okay? And that's all really good. And then we've also got other lessons. So let's just go back here to programming because, you know, not all of the lessons are free. So some of the bigger lessons, like this one and the one we're doing today on functions, because it took us a lot of time to put this one together, thinking of the best way to teach functions to people. This one on ASCII codes and regular expressions validation. There's an outline of the lesson. And when we look at the contents, this was a huge lesson. Like, this took us so much work to do this, teach it to you, supply all the code for you. So look, this is a paid lesson. You can watch the video for free as many times as you want on YouTube. But if you want to actually get the program code and the other sort of resources that come with that, especially if you're a teacher, I mean, this is a great learning resource you can give to your classes of up to 30 students. And look, the prices, guys, are just so cheap. If you just want to get a single download to use yourself, to learn some stuff, you know, Australian $2.50, less than $2 US. It's, you know, you go into a petrol or gas station to fill up your car, you can buy some tiny little candy bar, right? And it's going to cost you about the same as this lesson. So the price is minimal. It's like just a tiny little candy bar is all you're paying. And candy bars aren't good for you anyway. So get this lesson instead. It's a lot better for your health. And look, you buy them securely through PayPal, so there's no problem about that. This is the individual one. If you're a teacher and you want to get, you know, 30 lessons or a license for 30 of your students to use that, if you're a teacher instructor, just click this one. And the price, yeah, again, ridiculous, like less than $4 US. Not sure with the Australian dollar, its value, how long we can keep these lessons as cheap as this for you. But look, they're a bargain. And you know, people say, oh, well, everything should be free. Well, no, it shouldn't be free. That was a lot of work to make that. And, you know, help us out so we can make more videos just by getting a lesson here and there. Help your students out to learn faster. Even if you only use part of the lesson, maybe you just take the program code from the download and you want to take some pieces out of that and just make a little folder your students can use that's just got some handy little snippets of code there. So, you know, here's a little day's difference function, here's the code and here's how you call it, and just put that onto your learning management system for your students. You're welcome to chop up our courses and kind of redistribute them to your students in any manner you like, you know, once you've bought them. So that's no problem. Anyway, we better stop talking and get this video finished. And where are we? I think we're just there. All right, so Thanks for watching. Hopefully this has clarified things about functions. Remember to just think of it as the vending machine. There's like 2 coins going in plus a number, and then the machine's going to do all the work and it's going to put an answer out to you. Then you need a variable for the answer to go in. That's like where you hold out your hand and say, give me that candy bar, but don't buy that candy bar. Buy a lesson off Passy's World of ICT instead. Okay, so I'm not sure what our next lesson is, and this video was a couple of days late, but we will see you in the next lesson. Subscribe to our channel. We're putting out videos every week.